So welcome to my talk about Punishable AI, examining users' attitude towards robot punishment. My name is Rossmy, and I'm giving this talk on behalf of my co-authors Sarah Völkel, Elias Naphausen, Patrcia Kimm, Alexander Wiethoff, and Andreas Muxel. So today, more and more self-learning systems enter our daily life. For example, industrial robots, vacuum cleaning robots, but also self-driving cars on our roads or personal assistants on our smart devices. And if we observe them, we can see that these systems do not longer use deterministic algorithms, but instead use machine learning approaches instead. So the problem with machine learning approaches is that they are really hard to debug and analyze, but we still need somehow to design these systems that every user, like elderly people and novice users, can give feedback to these machines. So if we look into interhuman interaction, we can find punishment and reward as a familiar teaching strategy. So maybe we can take this metaphor of punishment and reward and transfer it to technology. And the interesting thing is that some people actually already perform punishment of devices. So some people, they are scolding their smart assistants, they are like screaming at their PCs, or they are smashing their keyboards if they're frustrated about technology. But the actual question is, if we would implement punishment, how far are people willing to go? What is users' boundary regarding the use of punishment? And at the same time, what are reasons for and against the usage of punishment? So if we look into the related work, we can see that it's heavily investigated and there are a lot of different punishment techniques out there. So we defined 5 design dimensions to classify, discuss, and compare these techniques. So if we, for example, take scolding. Scolding is non-corporeal and it doesn't involve you with like physical contact. The body state of the robot is the same afterwards, and the consequences, they are just temporary, so you can repeat the punishment. The robot is maybe looking sad, but still it's continuing to do the same afterwards. So next extreme thing is the electric shock punishment technique, which is implemented in Milgram experiments recreation of robots. So here we are now in the domain of corporal punishment, but still the other dimensions stay the same. So there's no physical contact, the body state does not change, consequences are just temporary, and you can repeat it like with no limit, because even if the robot is faking its own death, you can just restart it and use it again. So the most extreme form of punishment is the killing of a robot. So it's still a corporal punishment technique, but now you're like physically involved. You're like taking the hammer and smashing the robot to death. Then the body state changes. It's broken. You destroy it. You physically destroy the robot. And thus the change is permanent. The consequence is permanent. This means you can only do it once. So this kind of permanence is really important for the meaning of the interaction. So it's quite meaningful because the users know they cannot return to the initial state. It's broken afterwards. They cannot fix it. So can we create the same meaningfulness, but can design a strategy which can be repeated? And so we designed the mutilation approach, where we incrementally destroy the robot. So here we break one leg. The broken leg is not fixable, but you need to break multiple legs to actually destroy the robot fully. So it's not unlimited, but it's also like multiple times applicable. So the design of the robot is heavily influenced by insects and spiders, because these animals, it's quite okay to kill them in our society. So it's okay to smash a mosquito or to kill a spider. And also the affordances of the legs is quite interesting. They are easy to break. So the study design, the major concern was to create a situation in which the participants can experience different punishment techniques, so that we can collect the reactions and get their feedback. So we had 20 participants and they had to train a robot, and the robot's task was, the learning task was to learn to walk a straight line, and if the robot failed, it had to be punished. And the participants had to perform different punishment techniques over the course of the experiment. So the robot was not actually learning, it was just like faking the learning, but still it's about like the experience of the punishment. So we made sure that the participants could abort the experiment, and we made sure that all the ethical measures were correctly implemented. So let's have a look at the video demonstration.
That robot, don't do it.
So as you see, we implemented a logical escalation pattern. We started with like a really easy punishment, scolding, which is quite familiar to all of the users. And then we continue with dazzling, which is somehow familiar to how dog trainers would use water pistols to train the dogs. And it's also quite similar to the electric shock example we previously discussed. And in the end, users had to break the legs. They had to mutilate the robot until it was dysfunctional. And we thought somewhere on the spectrum there's this boundary where people say, okay, now this is too much, so I don't want to continue. And we could actually observe that 3 participants of the 20 didn't want to mutilate and aborted the experiment at this point of time. So after the experiment, we conducted the semi-structured interviews, and we collected all the statements and clustered them and classified them in our codebook. So all our results are based on the codebook and the observations. So the major finding was that there is nothing like a clear boundary. So people dislike the scolding as well as the mutilation. And there's a good reason for that, because scolding, you actually have to believe that the robot can understand your words, that the robot is intelligent to a certain level. And on the other hand, the mutilation, you have to assume, you have to believe that the robot is able to feel the pain and can actually have emotions. And this is quite complicated to conceptualize, and we can see this problem on conceptualization if the robot is alive or lifeless in a lot of user statements. So for example, participant 24 stated, it was a bit hard for me, yes, because of course, even if it's just a machine, you feel that you heard it somehow. And here in the same sentence, the person attributes feelings to the robot and then justifies it because it's just a machine which cannot have feelings. So people were really like, they struggled a lot with this conceptualization. And that's one of the major reasons why they preferred the abstract punishment, because here it's really clear, it's like you're decoupled from the machine, you're just like pressing a button, you're sending a signal, receiving feedback. So this was something that people could accept to a certain extent. Still, they didn't like the dazzling, but it was like the most accepted one. So what is this project about? This project is mostly about sparking a discussion about the design of human-robot interaction. And we want to provoke your thoughts, because we are not advocates of robot punishment, of robot abuse. But based on our findings, you can ask 2 questions. The first one is, could pain-like responses prevent robot abuse? So if we implement pain in, for example, a service robot, would children stop bullying it in a public setting, such as in shopping mall? But at the same time, if we go this route, we can also ask the question, is this way of anthropomorphizing technology the right design paradigm? Or do we need a paradigm shift away from anthropomorphizing machines? So do we need to actually find designs which are like different for humans and technology, and then result in something in a like more than human-centered design? So please think about that, and please discuss it with your colleagues. So thank you very much for your attention, and please enjoy the rest of this conference.